Now we want to test our circuit, and in order to test it, we need to work on processing. So if now you can go and open this processing program, then before you can run it, you have to do a couple of things which are written in here in a couple of slides. I put processings. Okay, so because you maybe have a fresh copy of the processing 3.0, you're missing one library which I use in this program. The library I am using is this. It's called Control P5 library. So the processing program is written in the Java language, which is very similar to C++. So this program needs to have two libraries which are other pieces of code written by somebody else. So one is written by, let's say, the processing teams, and this is processing.serial.star, and it's a library, a piece of code that is used in order to manage the USB communication. But then there is another library which is not coming from the processing, but is coming from a person that has written it, and this library is called Control P5, and it's a library we use for the graphic user interface, so the thing that creates buttons and such kind of things in let's say, that allows you to visually control things and also other things. So this library Control P5 has to be installed. How do you do this? So it should be not so difficult. So here I show you this slide. So you go here, and probably what you see is this wiggled line telling you that there is a problem with this missing library. So the package Control P5 does not exist. Okay, so if you are at this point, then let me change the figure. Then you have to add it. So you go here, you go on the Sketch tab, Import Library, Add Library. So Sketch, Import Library, Add Library. Once you are there, you have to install it. So you go on this tab, Libraries, you write Control P5, and this library should be present as an available library, and then you go and you install it. And then step number 4, once you did this, then you have a green mark here that is telling you that everything is okay. Now you have this library downloaded and installed. So this is just the result of clicking install. And finally, we are here. Now you can try to run the program by clicking this play button that you see on processing. in the window where you open the program, but you still might have a problem. It might say that you can't connect to the Arduino serial port. Okay, so if this happens, we need to select the serial port on Arduino according to what you have on your PC. So in the header of this small program.
Sorry.
Yes.
Sorry for interrupting you, but we're having problems installing. Like the computers are taking too much time. Maybe they're kind of crashing. So we are slightly different. Sorry.
Okay, so you have problem installing the Control P5 library.
Yeah. So there is one person having troubles with that.
Okay.
So, okay. So let's.
Okay.
Okay. It's just that they found it and they click on install and their computers are a little bit stuck trying to install.
Okay. Does it happen only on that computer or on every computer you have
No, it's happening in 2 different computers.
Okay. Is there anybody that could successfully install that library?
Yes, I have installed the library.
Yes, also I was able to install it, but now I tried to run and the program crashes. I don't know if maybe it's my computer that...
No. If you have the library, now the program is crashing because we are still missing one thing, which is setting the appropriate COM port.
Okay.
So, which is the thing that I was going to say right now. So the first thing is to have this green thick after you install the library, and that means that you have it. The second thing is to select the COM port in your program. So if you remember, just a while ago we went through the device manager of Windows in order to discover which one was the COM port connected to Arduino. So now one thing that maybe I forgot to say, and it's a good idea to do, is to close the Arduino IDE. So close the Arduino software, because it might lock the Arduino port, because it might hold it for program it. But now we already programmed it, so we don't need to have this port connected to the Arduino IDE. We want to have this port connected to the processing. So we need to quit Arduino after having programmed the Arduino board. Then it might be that we need to close and reopen the processing. And then we have to do this thing that is written here in the header of this processing program, the serial plotter. We have to find out where we have our Arduino, and then we have to go in this code, we have to find this line of code, Arduino equals new serial, this comma serial list, and then there is a number. So this number is according to the number you see here, 0, 1, 2, 3. So this is the enumeration of the COM ports that processing can find to be present on your computer. To be present, it means that, for instance, COM1, I don't know what it is, maybe it's the keyboard, COM3, in this case I think it's the Arduino, COM6 might be the mouse, and other devices like this. So if you know which is your COM port corresponding to your Arduino, then you go to this line. So let's try to find it in the code. It's here. It should be line number 81, and you put that number in place of the number which is present in this code that by default maybe is 1. Then you put the number you have, and then if you try to run it, it will run. If you still have problems, try change that number. So if I run this program now, for instance, let me do it. Okay, I reduce the zoom. So if you see at the bottom, you have a numbering here. You see 0, 1, 1, 3, 2, 6. So these are the COM ports that have been found on my PC. And one thing that can be also another problem, I don't know when you downloaded this zip file from GitHub, because a few days ago, just before the beginning of this practical course, I realized that there was a small bug in the program, and I corrected it, and I uploaded the correction on the GitHub. But if you downloaded this maybe a week or a couple of weeks ago, it can be that you still have that bug in the program. And so just for safety, I suggest you to re-download the code now. But if you did it on yesterday or the day before yesterday, it was already fixed. So if everything goes okay, then at a certain point you should have such kind of window with a green line and a sort of messy signal like this, which is messy because we have not connected anything to the inputs, and this is representing the signal we are amplifying, and so on. So is there anybody of you now that reached this point where you see this window with this green line?
No, mine is showing an error.
Okay, so which error is it showing?
Let me share the screen.
Okay, so I stop this, and if you want, you can also share the screen.
You have to allow it.
Yes, okay. I have to allow you. I can never remember how to do it. No, I stop the screen sharing. Okay. Multiple participants. Okay. Okay, now you should be able to share your screen.
Okay, this is the password.
Okay. Array index. Okay, so in place of at line 81, try putting 0 in place of 1, because you see it is telling you that you have a COM3 port numbered as 0. Okay, now you have it. Good.
Oh, thank you.
You're welcome. Is there anybody having similar problems?
Yes, in my case, it's still crashing every time I try to open it. It stays charging and nothing happens until the window freezes. So I just downloaded the GitHub again, and I will try that. I also disconnected everything. I will try to
Okay. Okay.
fresh.
It is not necessary that you reprogram the Arduino, because you already did it. So the only modification I did was on the processing.
Okay.
Some problems in the sense that in my case, serial plotter didn't show any errors, but when I press play, it opened up serial plotter, but it's empty.
Okay.
There's nothing.
And did you also download the code recently, like a few days ago, or long before?
Days ago, I mean.
A few days ago. Okay. Could you share your screen so I see what's your problem? Okay. Maybe one problem is that you haven't closed the Arduino Ide, so it is possible that that thing is locking the serial port. So in this case, just exit the serial plotter, exit Arduino Ide, and try to okay, exit this. No, that one was okay. Stop the button. Okay. No. Just close the program with the X here, the Arduino Ide. Okay. Okay. Then stop the program with the stop button. Play the button again. I see that there is something like Windows Defender on the background. Maybe that is telling you something. Okay.
No, the Windows Defender was about another program. I just closed it.
Okay. So maybe the program is running. So try to exit the program with the exit button. Okay. Then go in the folder where you have this program. So the serial plotter folder. So I see a couple of text files, this data underscore 2022 whatever. It means that it recorded something and it's there. So maybe the problem is that the output of the circuit is completely out of scale. So that might happen for two reasons. The easy reason is that this knob, the one that is set in the virtual ground level, is not at the correct level. So it has to be at the middle of its span. So let me try to get another trimmer here from the Arduino kit. So okay, I maybe don't have it. Sorry. Let me check if I have it here. Yes, I have it here. Okay. So if you now I share the screen, so okay. So if you take one of the trimmers and you insert this little thing in it, then you can rotate all the way left, all the way right, and try to understand where you put it exactly in the middle. You can't rely on the position on this arrow, because if I don't rotate and I disconnect this thing and then I move it a little bit and I reinsert it like this, then of course it's not pointing in the right position. So try to find a way of putting this arrow maybe like this. Let me try to see. Okay, you see now I inserted this knob in a way that if I rotate it full at right like this, then the arrow is pointing right at bottom. Then if I move it like this, it's pointing left bottom, and then if I put it exactly like this, it's in the middle. So if you do this, then this should have the correct offset voltage, which we can also verify with the multimeter, by the way. So if we go here, we take our multimeter, we turn it on, let's say in the 20 volts range, then we plug the negative to the COM and the positive to the voltage port. Let me see if we can do this. So we go here, then we want to measure the central pin of this trimmer, which is this pin here. So we have to touch this, being careful not to short circuit things with the tip of the probe. And so in order to test this, we need to connect one probe, the negative one, to a ground, to a GND. And so we know that GND is going to the circuit by means of this black wire here, GND. So if we follow that wire, our GND is on this stripe here, and so we can just touch here the edge of this terminal of this green bridge, and with the other terminal, the red terminal of the multimeter, we can go to the center of this trimmer. So we do something like this. So we keep one here and the other one here, and here, okay, it's not 2.5, it's 3.85. In my case it's a little bit higher. So you can try to turn this trimmer up and down and see whether you can see the track appearing in the virtual oscilloscope. This will basically move the offset of the ground and will shift all the levels. And while doing this, it's better if you connect a known source of voltage to your circuit, and what's better than putting everything connected to ground, so to zero, so you can do all these things. So you connect all the electrodes together. So now the circuit is supposed to measure 0, and if we go here, let's see what happens. Okay, I zoom it a little bit. So now I am on this condition, and if I rotate the trimmer, you see I can move the track up and down. So you can try to center it this way on the screen. Then if you disconnect it, the crocodiles, then you should have a noisy signal. So let's try to do it again. We connect.
Excuse me?
Yes?
I have always the line like this.
Even if you disconnect the probes?
Yeah, yeah.
Okay, so try to touch the probes with your hands and see if something moves.
Touch. There is no signal also if I touch.
Okay, so that might be an indication that there is something wrong with the circuit. But does
Maybe the resistance is not put in a good way.
Let's do one thing first. So let's connect again everything together to the ground like this, and let's try to verify whether you can move up and down the track by acting on the trimmer. Does the track moves?
No.
Okay, so it means there is something wrong with the wiring of the circuit in the breadboard. So maybe if you carefully inspect, there is some connection. It can be more than one, which is not according to the schematic diagram.
Okay, maybe I check
Okay.
some.
Is there anybody that having all the electrodes short circuit together can have this situation where you can have this track most on the middle and you can move it with the trimmer? Is there anybody that could do this?
I set the trimmer at 2.5, but I still have the black.
Okay.
Not 0, 0.
Try to move it more and see if you can see something.
Okay.
Meanwhile, I do another thing. Let's double check another thing. At line 90 of the code, do you have this value offset equals 64?
Yes.
Okay, now that should be correct. Okay, meanwhile that somebody is checking the the circuit, let me do one thing, which is discussing this code. So
Just a moment.
yes.
Can you just confirm that is this how it is supposed to be?
Excuse me, could you repeat, please?
Is this how the signal is supposed to be? Like I just shared my screen.
Okay, so let me stop the sharing. So I stop the sharing. Yes, it can be something like this, but can you try to short circuit all the crocodiles together?
How am I supposed to do that?
Sorry, I now I show you. I show you. So I activate my screen sharing. Okay. So
I need to stop.
so it goes like this. So these things they have a plastic part. You see there is a sort of bulge here. If you push it firmly, it will open. So if you make it biting something like your finger, be careful because it can be not very pleasant. So you do something like this. I'm putting the fingers like this. If I retract this, then you see how it's made. So it's a mechanism like this. There is a spring. So now I'm putting this plastic part back. So if you push it, you can open and close it like this. Then you can do the same with two of them, and you can connect it like this, and also a third one you can connect it like this. Now everything is connected together. So the signal electrode, the reference, is connected to the ground. So if you see this, if you do this, then you should be able to see a flat line. Do you see the flat line now?
Just a moment.
Okay.
I do get a flat line with where some spikes every so often.
Okay.
So, but in general, it's a flat line, and compared to the other situation when they are all apart, the difference is
Okay.
is huge.
Okay. So okay. So probably your circuit is working. Okay, so let me proceed with one thing. So now,
Okay, like
Sorry.
this?
okay, let me deactivate my screen sharing. Okay, now you can share the screen. Okay, it looks correct. So if you move up left and right the knob of the trimmer, you should be able to see the track moving up and down. Okay, okay, okay. Try to put it a little bit higher. Okay, maybe it's working. Okay, so let me tell you one thing before your hard disk will explode. So you see there is in serial plotter in processing two buttons, play and stop. So now stop the button. So push the stop button or exit the app.
You have to share your screen again.
Yes, sorry, you're right. So let me share the screen. Okay. So now exit the program or push the stop button. So to stop the program and go into the folder where you download everything. You go in processing, serial plotter, and have a look of those files. So every time you run this program, it will create a file like this. So you see, the more you stay there, the more it records, the more it fills this file. So now I have two files. So if I select this one, which is probably the last one, so it's already around 100 megabytes. So it records quite a lot of data. So in doing these experiments, don't leave your computer recording for hours or half an hour, because then you will have gigabytes of files probably very easily. So while experimenting with this, sometimes stop the program, check this folder, and you can just select those files and delete them, because they are produced every time you run the program. And it's not that the data are overwritten every time. Every time you run the program, it creates another file with date and time. So you have a new file every time with a new name. So that's the first thing to know with this little program that I wrote. So in order to try to debug it, let's try to quickly understand how it works. Then my idea is to try to do a practical demonstration of how to place the electrode and what you should be able to see. And then my idea is that once you know those things, we can try to debug your setup. Okay, so now basically this software works like this. So it's written in Java, we said. Okay, so on the right you have comments. I try to put one comment per each line of code in order to explain what it is doing. So there is a first part where we have the declaration of some variables like the data, the offset, the baud rate, which is the speed of the serial port for Arduino, the communication, and then those four things: XA, YA, XB, YB, which are the coordinates of 2 points in these plots that you see. So similarly to Arduino, you have a setup function, and now this setup function is getting the year, month, day, hour, minute and second, and is defining a file name, data underscore, and then those things here will be used in order to create the file name of the file that is going to be recorded. Then you have the creation of a window with this size, 1000 by 400 pixels. You can change it whatever you want, but for the moment I suggest you to leave it like this. Then there is the creation, instantiation actually, of this object control P5, which is the thing that we downloaded with the libraries in order to be able to use such kind of features like buttons. So here we are creating a button. This is the button with label 13.5 kilohertz. So if you press that button, it will send that code through the serial port that Arduino will understand as the code in order to make the selection of the prescalers of the ADC in order to work at that data rate. Similarly, the button B and the button C. Then there is also a button D, which makes the program to exit. So here what I'm doing, I'm printing at the bottom here the COM ports that I can find on this computer, and I'm telling the program to open a serial port object I called Arduino, because this serial port is connected to the Arduino, connected to this port 1 or 0 or 2 or 3 or whatever number you have on your computer, with the baud rate that was specified at the top, which is the the highest baud rate the Arduino can deal with. Okay. Then I create a buffer for the data, which has the width of the window that I'm using. Sorry. And similarly here. Then these are two instructions that are used in order to set up the color of the line and the color of the background of the window. Excuse me. And then I start with the point X, sorry, the point A, by setting a coordinate equal to 0. Excuse me. I needed a glass of water. And the second point B, which is a point having coordinate X on the plot, which is the coordinate of the point A plus 1. So basically I'm creating points, subsequent point one after the other one. So what I'm doing then, I'm filling this file name with a string corresponding to the date and time, and I create the log file.